Have you ever felt like reality is off? Like something isn't quite right in the world around us? Well, get ready to question everything you thought you knew. In this video, we are diving deep into the simulation theory and uncovering 10 chilling clues that suggest our existence might be nothing more than lines of code in a hyper-realistic computer program. Starting off, we are talking about the argument of high probability. Some philosophers, like Nick Bostrom, have cooked up a theory that feels like it can't be real, but it is actually taken quite seriously by some scientists. They say there's a high chance that we are living in a simulation. Bostrom argues that one of these three scenarios is probably true. First, that extinction is the norm. Almost all civilizations out there, like ours, never make it past a certain point. They wipe themselves out or get destroyed before they can really get advanced technology. It's a little bit terrifying, right? Imagine countless civilizations reaching the brink of greatness only to fall into the abyss of extinction. It's like cosmic Russian roulette. The second scenario is that no one's playing games. The advanced civilizations that do make it decide running simulations of their past, like their own version of super advanced ancestry.com, is boring or pointless. So they don't bother creating these massive virtual worlds to see what their ancestors were like. The third scenario is that this is all make-believe. Definitely the scariest of the scenarios, that we are actually living in a giant computer game right now. That our entire universe with its stars, planets, and morning coffee is just some super advanced alien software running on a cosmic computer. So why is this unsettling? Well, if we're in a simulation, then who's controlling it? What happens if they decide to hit the off switch? It's like being a character in someone else's video game, and it makes you wonder, are our choices really our own, or are we just following the pre-written code of some cosmic programmer? This theory gives a whole new meaning to the question, what is reality? And honestly, it's a little bit spooky when you really think about it. Next, we are talking about the second law of infodynamics. So a physicist studying the mutations of the SARS-CoV-2 virus has stirred up quite the conversation with claims that hint we might be living in a simulated universe. Dr. Melvin Vopson, the scientist behind these claims, introduces, quote, the second law of infodynamics, suggesting that mutations in the virus aren't random but follow this new law. He's found that information entropy, a measure of disorder from an information perspective, decreases over time in these mutations, opposing what we see with typical entropy, which increases. This discovery is more than just a quirky observation. Vopson argues it could flip our understanding of evolution on its head and even hint at a universe that's more orderly and deterministic than we thought. He connects this to the idea that the universe might be a giant simulation, designed with data optimization to minimize computational needs. In his studies, particularly with the ever-mutating SARS-CoV-2, Vopson has observed patterns that he believes can't be dismissed as random. He suggests that if we start viewing genetic mutations deterministically, we could potentially predict mutations before they happen, which could revolutionize genetic therapies and vaccine development. However, the physics community is still skeptical, and more research is needed to test these very bold ideas. Vopson's theory, while intriguing, remains on the fringe, and proving it might involve experiments that check if information itself has mass, a concept that could tie back to everything from the heat death of the universe to why symmetry is so common in nature. So while the second law of infodynamics opens up fascinating possibilities, it is a long road from hypothesis to accepted science, especially with claims this big. But who knows? Sometimes the strangest ideas lead to the most profound discoveries. Next, we are talking about the limitations in the laws of physics. So think about the speed of light. Nothing can go faster, right? It's like the universe has a top speed limit, and no matter what you do, you can't break it. This reminds some people of a video game, where the game can only process things so fast, so it sets limits to keep everything running smoothly. Then there's the Heisenberg uncertainty principle, principle, a weird rule in quantum mechanics that says you can't know both the position and the speed of a tiny particle at the same time. It's as if the universe saves on processing power by not deciding where something is until it absolutely has to, kind of like a game that only loads the parts of the world you're looking at to save memory. These rules of physics might make you wonder if they're just programming constraints in a giant cosmic simulation set up to keep things manageable for whatever's running the show. Isn't it a bit like we're living in a cleverly crafted game where certain things are off limits to prevent the whole system from crashing? It's definitely a wild thought, but it sure makes you look at those science class lessons a little bit differently. Next, we are talking about the observer effect. So have you ever heard of the downright bizarre behavior of particles in the quantum world? In quantum mechanics, things get really weird because particles, like electrons, don't settle on a specific location or path until we actually check up on them. Kind of like they're all potential and no decision until observed. This quirkiness is known as quantum indeterminacy and the observer effect. So now, think about how video games work. Alright, it's just the easiest parallel, so there's going to be a lot of video game talk. They don't bother rendering every single part of the game world all at once. Instead, they only show you what's in your current view to save on the processing power. It's like the game is saying, why bother with the rest if you're not even looking there? This is eerily similar to what's happening at the quantum level. It's as if our universe is running a super efficient simulation, doing calculations only when necessary to make sure it doesn't waste any resources. This parallel makes some folks wonder if maybe, just maybe, we're living in some sort of cosmic video game where things aren't fully decided until they need to be. Next, we are talking about mathematical consistencies. Have you ever noticed how everything in the universe seems to follow a specific set of rules, almost like it's all part of a gigantic mathematical equation? Pretty wild when you actually think about it, from the way the planets orbit the sun to how your coffee spreads out when you spill it. There's math everywhere. This isn't just a coincidence. The universe is actually incredibly consistent and can be described really well using mathematical principles, just like a computer program. This consistency is what gets some people thinking. Maybe our universe is a bit like a game or a simulation. I mean, really just think about it. In video games, everything from the graphics to the physics is governed by code, by math. So when scientists find that even the most chaotic and complex systems in our universe can still be nailed down with equations, it makes you wonder if there's some sort of computational foundation underneath it all. So why is this exciting? Well, it suggests that maybe our whole universe could be running on a vast cosmic computer with every star, planet, and galaxy following a set of mathematical instructions. It's like the universe is a giant puzzle and math is the key to unlocking its secrets. I feel like that's a nightmare for a lot of us. Like, oh no, not math. The one thing I can't understand. I actually like math. Well, I guess we all have to. Next, we are talking about the anomalies in the cosmic microwave background. So for this one, we are taking a look at the universe's oldest light. That is the cosmic microwave background, also known as the CMB. This is like the universe's baby picture taken shortly after the Big Bang. Now, this light should be pretty uniform, but scientists have noticed some weird patterns and anomalies in it. It's as if the universe has a slight glitch or a kind of a cosmic watermark showing up in this ancient glow. Some folks think these odd patterns might be like the digital artifacts you see in images that have been compressed too much, or when your video game starts showing weird lines because of a graphics bug. What's super intriguing is that these anomalies could hint at a digital grid or a kind of underlying scaffold to space-time, sort of like how pixels build up your screen. If our universe were a simulation, you might expect to see some clues at the largest scales, and these odd patterns in the CMB are like potential Easter eggs left by the universe's programmers. Next, we are talking about Gödel's incompleteness theorems. So these theorems are like the ultimate brain teasers of the math world. They tell us that if you have a robust enough system of math, the kind you could use to describe, say, the entire universe, there are always going to be some puzzles you can't solve, no matter how hard you try. It's like having a never-ending list of riddles where some just don't have an answer. Now, think about a computer simulation. Even the most powerful video game or simulation has its limits. There are certain things that it just can't compute, or display. Gödel's theorems suggest something similar about our universe. There might be cosmic rules that are kind of like a computer's programming constraints. These unprovable truths could mean we're in a giant cosmic simulation where some things are set up just so the system can keep running without crashing. It's a mind-bending idea that maybe some of the mysteries in the universe are unsolvable because they're built into the code of our reality. Next, we are talking about the bootstrap paradox, which in physics is like a cosmic chicken or the egg scenario that really twists your brain. Imagine you write a story where a scientist receives a mysterious notebook from the future filled with ideas that they then publish. Where did the original idea come from? Similarly, in physics, we have laws that could potentially explain how entire universes, including one like ours, might be created. It's as if the universe could contain the recipe for making more universes, including itself. This kind of mind-bending, self-creating loop is like a video game where characters discover they can design and spawn new levels or even new games from within the game they're already playing. It suggests our universe could be just one level in an epic cosmic game, constantly spawning new universes in a never-ending cycle. So next time you're pondering the mysteries of the cosmos, consider that maybe we're in a universe that's bootstrapping itself into existence. Next, we are talking about the black hole information paradox. Imagine you toss your favorite book into a black hole, a bit dramatic, I know. According to the rules of quantum mechanics, the information in that book should be preserved somewhere, somehow, because in the quantum world, information never really disappears. But black holes, these cosmic vacuum cleaners, seem to suck everything in and let nothing out, not even light, which makes it look like the information just vanishes from the universe. This dilemma is what scientists call the black hole information paradox. Now here's where things get really sci-fi. Some smart folks think this paradox could be a clue that we are living in a cosmic hologram. They suggest that all the information swallowed by the black hole might actually be stored on its surface, kind of like how your phone stores stuff in the cloud. I'm still trying to figure out what the cloud is. This idea is part of the holographic principle, which hints that our entire 3D universe might be a projection from a 2D boundary. This very mind-bending concept fits nicely with the simulation hypothesis, suggesting that what we experience as three-dimensional could be just another level of grand cosmic simulation. And finally on our list today, we are talking about tampering with the experiment. So imagine if we found out for sure that our whole life is just a massive computer game and everything we've just spoken about is in fact true. Now that's what Professor Preston Green from Nanyang Technological University in Singapore is thinking about. He's pretty worried that if our scientists ever manage to prove that we're living in a simulation, it could cause a huge mess. So here's the deal. According to Green, if we start running experiments and suddenly figure out that yes, we are indeed a simulation, this could really mess up the whole point of why we're being simulated in the first place. Green suggests that if we get too nosy and prove that we're just bits of data in a cosmic computer, the beings running this show might just hit the off switch. Why? Well, because if we know we're in a simulation, then we'll probably change our behavior so much that the simulation stops being useful for whatever questions our creators are trying to answer about their own world. So, while it's fun and kind of weird to think about being in a giant video game, Green warns that proving it could lead to game over for all of us. So just be careful, you know? They have questions for us, buddy, I got questions for them, okay? Alright guys, that has been our list for today. Thanks so much for checking it out. I've been your host today, Levi Kozlowski, and I will see you all again very soon, I'm sure. Goodbye!